My name is Nicolas Deixonne, and I'm very, very glad to be here today to talk about the fault tolerance of Openstack. So I'm working with in my project in IT Master at ETS, École de Technologie Supérieure, with my professor Abdelwahid Gerbi, and in collaboration with Ericsson, Ali Kanso. I would like to thank, before to begin, also Clément Contini, because it's thanks to him I have this project, and he worked before me on this project. So a very small plan. So firstly, I will make a difference between Hive Ability and the fault tolerance, talk about the environment we use, Openstack Mirantis, what is the Nova component, what we have developed to test the fault tolerance of Openstack, what we have developed also to enhance the fault tolerance of Openstack, and of course, a conclusion and a future work. So firstly, before to begin, it's important to understand the difference between high availability and fault tolerance. The high availability, to understand the high availability of a service, you need to understand the availability itself of a service. The availability of a service is a given duration where you can access a service in the cloud, okay? So generally, we calculate this availability as a percentage. And we consider a service high available if the percentage is superior than 99.999. Means that you can, the service should be downtime for a maximum of 5 hours in 1 year. So generally, we perform high availability thanks to replication. So here, we have 3 nodes, for example. Nodes represents machine, different machines, and you replicate a service 3 times, for example. And here you have load balancing, okay? It's like a sort of gateway, so the user will go to this load balancing, and the load balancing will be able to distribute the job, the task, to any available node. So that's the high availability. But now the fault tolerance is totally different thing. The fault tolerance means to ensure the service continuity even if something failed during the process. Means that the node actually has already received your request, but something happened during this process, before the end of this process. And so if a service or another replicated service is able to take your previous task, which is given up normally, then it's fault tolerant. And so let's go. So to test the fault tolerance, we use the environment of Openstack provided by Mirantis. So just as a reminder for people who don't know very well Openstack, Openstack is an IaaS, so infrastructure as a service, and that allows you to manage VMs, network, storage in the cloud. And so we use the Kilo release of Openstack. The Kilo release is one of the latest release of Openstack, okay? And we use Mirantis. Okay, Mirantis provide us a tool to deploy automatically and very fast a highly available environment of Openstack. So here, as you can see, we have Openstack replicated 3 times in different nodes. And we call the node where Openstack is installed the controller node. So here, Openstack is composed of several components to perform storage, management, VM management, security, network, etc., etc. And you have other type of node, like the compute nodes. The compute nodes are, in fact, the nodes where you instantiate your customer VMs or your customer containers also. And you have other type like network node or storage node, but I will not talk about that because the work focused on compute nodes. So to begin with, we needed to test the fault tolerance of something. So we decided to test the fault tolerance during the VM creation in the Nova component. So what is the Nova component? The Nova component is one of the most important components in Nova. That allows you to manage all your VMs, and also containers, because it's also compatible with containers, and add VMs, delete VMs, etc., etc. To test the fault tolerance, in fact, we needed to stop the execution flow when a user wants to create a new VM. So we needed to understand all the execution flow, all the process when a user wants to create a new VM. So now, here is the architecture of the Nova component. So it's composed of several services, Nova API, Nova Conductor, Nova Scheduler, Nova Compute. So when a user wants to create a new VM, then Nova API will get the request for you. Nova API will be responsible to send to Nova Conductor the request. After that, Nova Conductor will send the request to Nova Scheduler. Nova Scheduler is responsible to get for you an available compute node where you can instantiate your VMs. And after having this information, the Nova Conductor will send the final request to create the VM to the Nova Compute. It's important to know that the Nova Compute service is on the compute node, not on the controller node. So those services run on the controller nodes, and this service runs on compute nodes, different machines. So we needed to test the fault tolerance of Openstack. To do that, we needed to have an Openstack testing framework to inject fault and to stop the process during the VM creation. Okay? And we developed it, and this framework is called TestStack. So what is a fault? To understand what is a fault, in fact, the fault is a very small script we inject in the Openstack code itself. And when this small script will be executed, then the service where the fault is executed will be stopped and will be restarted later. And why we do that? It's because we want to check if in Openstack there is a behavior to check to ensure the fault tolerance. Means that something Openstack has a behavior to take your previous task, your previous VM creation request. But if there isn't any behavior for that, so it's not fault tolerant. So we begin to inject our several locations, like before and after sending a request from a component to another one, from a service to another one. After receiving the request from a service to another one. And so firstly, we inject, for example, here. So before Nova API sends a request to the Nova Conductor, what we have is in fact a 502 error, means we lost the connection with Nova API, so with OpenStack, but it's normal because we kill the Nova API before Nova API has time to send a response to the end user. What is not normal is we have an inconsistent state. Indeed, a VM will be blocked forever in building state. That's what we have seen. You want to ask something? Oh, sorry, no. Okay. So the VM will be blocked forever in building state. And why it's happening like that? It's because, in fact, in the Nova API changed the database and adds this VM you wanted to create, okay? But in fact, the request will never reach the Nova Compute service to instantiate your VM. So the VM is still in your database, but nothing happens, and the user has no ways to know it. So that's a case. Another case, when we inject a fault after sending a request from Nova API to Nova Conductor, then we have a 502, we lost the connection also, because we kill Nova API before sending the response to the end user. But the VM will be in correct state, because, indeed, here, the request can reach the Nova Compute service to instantiate your VM. But most problems happen here, in fact. So why we have a problem? In fact, here, Nova API will be able to send a response to the end user, but here, we stop each time the flow execution flow before the Nova Compute service can instantiate your VM. So what you have, it's logically, you have a 202, means normally your VM should be correct, in correct state, and should be in building state. But in fact, it will be blocked in building state in appearance. And so it will never be active state. Just as information, yeah, because I forgot, but a VM can have several states, okay? And we focused on two states, the building state and the active state. Building state means your VM is being built, and active state means that your VM is well created. And you have last cases where it's okay because the Nova API is able to send a response and the request can reach the Nova Compute service, so everything is correct. But what we have proven with TestStack is that OpenStack is not fault tolerant. There is no behavior that if a task is given up, if something happened in your system, to take your previous task and not to give up this task. That's why we decided to create FFT Stack, a new component to enhance the fault tolerance. For that, we needed to define an extension okay, to mask the failures from the end users and ensure the successful VM container creation request. Firstly, we thought to modify directly the code of Openstack, but actually, fault tolerance is very complicated, and you need to modify the architecture of Openstack itself because it adds messages, etc., to register all of the transactions, to roll back, etc. So we decided to create a new component between the end user and the Openstack API. So thanks to that, FFT Stack is able to detect if something is wrong in the Openstack environment and is responsible to get correct VM for the end user. And of course, enhance the fault tolerance of Openstack during the VM creation. But here, there's a problem again, because FFT Stack became a single point of failure, and we need a highly available environment of Openstack. So we needed to replicate 3 times FFT Stack also, and we put FFT Stack in the 3 OpenStack control nodes, replicated 3 times. FFT Stack became a component, okay, like the Nova component. And one thing is important, the end user will access each controller thanks to a virtual IP. Virtual IP, as information, is like a failover mechanism. So for example, if a node 1 is up, the end user by default will be redirected on the controller node 1. But if this node is down, then the user will be redirected on the node 2. You have also, you can see A-share proxy. Okay, A-share proxy provided by Merentis, in the environment, is very useful because it's the component to ensure the Hive Ability of your service. So it's a load balancing at the application layer, and it is connected to all other components in OpenStack. And thanks to that, it's able to distribute the job in all your cluster in OpenStack. So now, for example, if the node 1 is down, then the virtual IP will be on node 2, etc. The same thing happened for node 3, as you can see. So now imagine the end user wants to create a VM this time with FFT Stack inside the system. What's happening? So imagine the virtual IP is on node 2, okay? So the end user will be redirected on node 2, of course, on the A-share proxy firstly, okay? The A-share proxy will be responsible to send the request to any available FFT Stack component. So for example, randomly, the node 3. After that, FFT Stack will communicate through A-share proxy to any available Nova component to ensure that the VM is well created, okay? And FFT Stack will be responsible to send the correct response to the end user. But it's not finished. FFT Stack needs to communicate through A-share proxy with any available Nova component to ensure that the VM state will be correct and not blocked forever in a dirty state, like building state. So that's what we have developed. We have tested OpenStack fault tolerance during the VM creation. It was just a beginning. And we have developed a solution to enhance the fault tolerance of OpenStack. Our future work is to extend test stack and FFT Stack to other components or other behavior in OpenStack, because test stack, actually, with test stack, you can inject faults anywhere, okay? And FFT Stack is connected to the API, so that's pretty generic. So you can very easily use FFT Stack and have control on the API of OpenStack. So last words, okay. Last words, very important. Fault tolerance increases the complexity, okay, much more. Because you need to add 3 features if you want to perform fault tolerance, okay? You need to have a monitoring feature, so to be able to monitor if something happened in your system, a notification feature to notify when and where the fault happens, okay, and register the transactions, and of course a rollback feature to clean the modification that your previous task has done, because you want to clean your environment and retry the request. That's why we did a new component, because modifying the OpenStack is very complicated, and you need to change the architecture of the Nova component. And actually, the current architecture is not for fault tolerance, so that's why we needed a new component. And so fault tolerance is like the security. You need analysis. You don't want to put everywhere fault tolerance. It's expensive. you need to add much more messages exchanging, and you need analysis to see where a fault can happen the most. And that's pretty it. So thank you for your attention.